Ladies and gentlemen, today we are looking at addition and subtraction of sets. So, we said two or more sets can be added or subtracted when they are like sets. That is, the numbers in the roots are the same. So, for example, when we have square root of 3 and square root of 3, they are like sets because the numbers in the root are the same. Let's consider an example here. We want to look at how to simplify square root of 512 plus square root of 128 plus square root of 32. Clearly, these are not like sets because 512 is not the same as 128, which is not the same as 32. So, what we need to do is we will have to try to simplify these ones to see whether we will get like sets from them. So, let's look at our solution. So, we are taking square root of 512 to express it as square root of 256 times 2. Then we are taking square root of 128 to express it as 64 times 2, where 64 is a perfect square. That is what is very important to us. And then we are taking square root of 32 to express it as square root of 16 times 2. Please, there was a video we looked at how to simplify sets. That was a previous video before this one. So if you have not watched how to simplify sets, then you might have a little problem here. So you need to go back and watch that video before you come and continue. Alright, so when we do that, we say that square root of 256 is the same as square root of 16 square. Then square root of 2 will stay here as root 2. Square root of 16 is the same as square root of 8 squared. And then square root of 2 stay here. And then square root of 16 is the same as square root of 4 squared. And then square root of 2 will stay here as it is. So at the end, when we simplify this, we are going to get square root of 16 squared will give us 16. And then this square root of 2 stay. Square root of 8 squared will give us 8. And then these 2 stay. Square root of 4 squared will give us 4. And then this square root of 2 will stay. So when we multiply, we are getting square root of 16 root 2, and we are getting 8 root 2, and then we are getting 4 root 2, and that is what we have over here. Now we have succeeded in making the sets become like sets. We have succeeded in doing that because the numbers in the root are now the same. You see root 2, you see root 2, you see root 2. So these have become like sets. Now, since they are like sets, we can now add them. So we add them because root 2 is common in all the three terms. Root 2 is here, root 2 is here, root 2 is here, is common. We'll factorize root 2 out. So we're going to have something like this. You're going to have root 2 factorized out. And then you will keep, when root 2 is out of here, when root 2 is out of here, we are going to get 16 left. When root 2 is out of here, we are going to get 8 left. When root 2 is out of here, we are going to get 4 left. So, when we then add these numbers, 16 plus 4 plus 8, we then arrive at 28. and we attach our square root to it. So this is our answer for the addition of square root of 512 and square root of 128 and square root of 32. Let's consider a second example. We have 3 over 4 square root of 128 minus square root of 50. Clearly again, these are not like sets because 128 is not the same as 128 is obviously not the same as 50. So we will see how to simplify this one as well. Now, to simplify this, what we will do is that we will try to break the square root of 128 down, simplify it, and then when we are simplifying, we are looking for two factors. That when we multiply, one is perfect, one is not perfect. When we multiply, we get 128. So that gave us so square root of 128 will give us square root of 64 times 2. 64 is perfect, 2 is not. Root of 50 will also give us 25 times 2. And then when we separate them, we'll have root 16 here, we have root 2 here, we have root 25 here, and then we have root 2 here. Our coefficient still stays as it is. Then when we move on to see how we simplify, you and I know that square root of 64 will give us 8. Square root of 2 will stay as square root of 2. That's irrational. Square root of 25 will give us 5. And then square root of 2 will also stay as square root of 2. Now we will realize that when we are multiplying these 3, a 3 over 4 times 8, something can be done. 4 will go into itself 1, and 4 can go into 8, we'll get 2 times. So these 2 will now multiply our 3 here, and that means we'll be getting 2 times 3. So our next step, we'll have 3 times 2, which will have it here, square root of 2. And then this will give us 5 square root of 2. So 3 times 2 will arrive at 6. And then this also stays as 5 square root of 2. Now square root of 2 is common in the 2 terms. So we prefer to factorize square root of 2 out, leaving our 6 here minus the 5. Now 6 minus 5 will give us 1 square root of 2, which is the same as square root of 2. And that brings us to the end of this example. Let's consider another example for better understanding. We want to look at the situation where we now combine the addition and the subtraction all together in one question. So we are looking at simplify 3 square root of 75 minus square root of 12 plus square root of 108, leaving your answer in surd form. That means that when you finish solution, your answer should contain a root. Alright, so let's consider the solution here. So So, taking our question from here, obviously you realize that these are not like size because the numbers under the root are not the same. So we'll try our best to simplify them and put them in the basic form to see whether they will become like terms so that we can add or subtract them. Now, we look at how to break these down. You realize that square root of 75 can be written as square root of 25 times 3. 25 times 3 gives us 75. We chose 25 because it's perfect square, and it's times 3 that will give us 75. Root of 12 can also be written as root of 4 times 3. And we choose 4 because 4 is a perfect square, and when we multiply by 3, we'll get what? 12. Root of 108 is also 36 times what? 3. We chose 36 because 36 is a perfect square. When we multiply by 3, we get 108. Now, to simplify this further, we're going to break it down and then make the square root of 25. Then we'll separate this one to a square root of 3. Then we'll have square root of 4 and separate this as square root of 3. Then we'll have square root of 36, and then this is separated as square root of 3. Now, then you realize that this our 3 was already a coefficient. The square root of the 25 gave us the 5. Square root of 3 still stays as 3, root 3. Then the square root of 4 gave us these 2. The square root of 3 gave us also still the square root of 3. Then we have root of 36 gave us the 6, and then square root of 3 remains the 3. So then when we simplify further, 3 times 5 will give us 15. Then we have 15 root 3. Then this also gives us 2 root 3, which we have here. And then when we multiply this one too, we arrive at 6 root 3. Now, we have succeeded in making the Surds like Surds because you realize that the number under the square root here, root 3, the number under the square root here, 3, the number under the square root here, 3 are the same. So they have become like Surds. Since they have become like Surds, then we can now add or subtract them. What we'll do is that we are going to factorize the square root of 3 out because the square root of 3 is common to all the terms. So you have 15 square root of 3, 2 square root of 3, and then 6 square root of 3. So square root of 3 is common to all of them. So what we will do is that we will factorize it out. So you have square root of 3 factorized out here. And when root 3 is taken off from here, we'll level 15. When root 3 is taken from here, we'll level 2. When root 3 is taken from here, we'll level at 6. So we keep this in bracket, in parentheses. Now when we further do the subtraction and the addition, we'll have 15 minus 2. That will give us 13 plus 6. That will give us 19. So in all, we are going to arrive at 19 root 3. And that is our final answer. This brings us to the end of addition and subtraction of Surds. Watch out for more videos and subscribe to my channel.